So, here's a couple people looking at each other. This person's way up here at the restaurant, looking down at this person on this observation deck. When you're looking down at somebody, you form from horizontal an angle of depression. Kind of like trig and geometry students. You become all depressed. You're in a state of depression when you're dealing with trig. Now, it's my job as a teacher to elevate you to happiness because you figured out trig. So here is a person standing on the observation deck, and from horizontal, when they look up at the person at the restaurant, that's an angle of elevation. So, angle 1 is an angle of depression. Angle 2 is an angle of elevation. Okay? So, if the person at the observation deck is looking at a person down on the ground, is angle 3 an angle of elevation or depression? Depression. And this person looking up at the person at the observation deck is an angle of elevation. Now, watch this fancy trick. What's this thing called? Protractor. Not that many of you can see this, but this is a 10-degree angle looking up here. Okay? How big do you think that angle is going down this other way? 10 degrees. Oh. So we got 10 degrees here and 10 degrees here. Why would they both be 10 degrees? You learned this first semester, chapter 3. Alternate interior angles. There you go, Nikita. Woo. Way to hold on to that important information. They are alternate interior angles because these are both horizontal lines. Horizontal lines are going to be parallel to each other. So whenever you have an angle of elevation, you're also going to have a matching angle of depression on the other side, which are alternate interior angles. All right. Good enough with angles of elevation and depression. You'll hit some of those on your homework. All right. So, when I was down in Daytona Beach, not last summer, but the summer before, they had one of these on the beach, and no, I didn't go on one of these. But they had one of these on the beach where the person stood here, and then all of a sudden they were catapulted up in the air, and they bounced up and down and up and down and up and down a few times, and then they let them down to the ground again. All right. So, how high is it, this, if they're going to catapult the person up and down, how high is the top of the tower there? Well, we assume that this is a right angle. Okay, they should say that it's a right angle, but we're going to just assume it's a right angle. This is a 70-degree angle right here. We have the opposite side, and we have 8 down here. Okay, well, if it's 8, and really the triangle's like this, and because there's so much clutter here, I'll redraw it over here. This is a right angle. This is a 70-degree angle. And because it's 8 between here and here, what's the short part from here to here? 4. That's all we need to know. I can figure out this side. How do I figure out that side? Well, here's my angle. This is the opposite. 4 is the adjacent. Opposite and adjacent is what trig function? SOHCAHTOA. Tangent. So the tangent of my 70-degree angle is my opposite side, x, over my adjacent side, 4. How do I get x alone? Multiply by 4. Take 4 times tangent of 70, somebody. 11.0 basically, right? 11 meters. Now, this person tied in they're tied off at 1 meter above the ground. So basically from the ground to the top of the tower, if we add 1 more meter on, it is 12 meters from the ground. The top of the posts are 12 meters from the ground. Okay? Okay. All right. Nadine is up here. She looks down to see a tour bus. She looks down at an angle of depression of 23 degrees. Okay? How far is the tour bus away from this 180-foot tall building that she's on? All right. So if this is 23 degrees, this is 23 degrees, right? We want to know how far away it is from the base of the tower. Okay? So this is opposite. This is adjacent. What trig function? Tangent. Tangent of 23 equals the opposite over the adjacent. Unlike the last problem, x is on the bottom here. We got to get x out of the denominator. How do we get x out of the denominator? Multiply by x. X tangent of 23 equals 180. Then how do we get x alone? Divide by the tangent of 23. What does x equal in the end? About 400-ish? 424. 424 feet. The bus is away from the base of the tower. Approximately. Okay, this one's a little more difficult. What's the measure of angle ABC in a square pyramid? All right. So, if we know this side, it'd be really simple. Because then it would just be a tangent problem. But we don't know that side. We don't know the hypotenuse. We know the height is 20. We know the length of this side is 20, but that really doesn't help us that much. So, what I need to do is find x here. So I look at the bottom of my triangle, or my square. It's 20 by 20 by 20 by 20, right? So if we go to the middle of the square, what happens is this makes a 45, 45, 90 triangle because it's a square, okay? And since these are right angles, you basically can make a square inside a square, and so it's a 45, 45, 90 triangle, which means this is 10, and how long is x? If it's a 45, 45, 90, 10 times the square root of 2. All right, so now we know this is 10 square root of 2. That's 20. And we want to know this angle. That's opposite. That's adjacent. Opposite and adjacent, what trig function? Tangent of my angle B equals the opposite side 20 over the adjacent side 10 square root of 2. Now, you got to know how to run your calculators. Okay? Because what we have to do is say we have to move the tangent to the other side, say B equals the inverse tangent of 20 over 10 square root of 2. But we need to put that in parentheses. Because if we don't, it'll be 20 divided by 10 times the square root of 2, according to the calculator. So you have to go 20 divided by, and then parenthesis, 10 square root of 2, and then there's probably going to be 2 parentheses at the end. Okay? So how big is my angle? 54.7. Okay? Takes a little more work for that one because we had to figure out that. All right. Last thing we're doing today is area. Now, most time when we're finding area of a triangle, we find the height and we go 1/2 the base times the height. And the base on this one is B, but the height, how do we find that? Well, if we know that this is 28 degrees, and we know this is 21, I know that the sine of 28 equals this over this. But we have a formula to make that a little bit quicker. Okay? It's called the side angle side area formula. The area of a triangle is 1/2 little a, little b times the sine of big C. So side A times side B times the sine of side angle C. Or the area equals 1/2 BC times the sine of A, or the area equals 1/2 AC sine of B. Now, in this case, I'm given angle A is 28, side B is 25, side C is 21. Which of the three formulas should I use to figure this out? The first one, the second one, or the third one? Second one, because it has A in it. So the area of this triangle equals 1/2 25, 21 sine of 28. So if you just plug that straight into your calculator, you can find the area super duper easy. What's the area? That's all you have to do to find area. As long as you have side angle side, it's really easy. So here's your three area formulas. And then you have angles of elevation, depression. So you can use tangent to figure that out, or sine or cosine if you need to. Okay? So you may get started on your homework assignment. It is out there for you. So get to work.